This is part 3 of exercise 17a, where we'll be doing the sums which were cancelled in the previous videos. So earlier there was a reduction in syllabus last year, but this year there are no cancellations in this exercise, so we'll be doing the remaining sums. Let's start with question number 2. Now make sure that there are no cancellations in solved examples or in exercise. All sums have to be done. Second sum. Diagram is given. Prove that AC is a diameter. The best way to prove that is by proving the angle subtended by it at the semicircle to be 90 degrees. That would prove that it is a diameter. So how do I prove this to be 90? Well, I just want to prove this to be 20. Then the total will be 90. So here are the steps. First of all, angle CAB will be equal to CDB, which is 45, cutting the same arc CB, that is angles of the same segment. That is the reason we give. Now total is 65, out of which this is 45, so how much is this? 20. Now this angle DAC and DBC are equal, again angles in the same segment, cutting the arc DC, both of them are cutting the arc DC. So this is 20, this is 20, hence proved. So this is 90, and if this is 90, then it is definitely a diameter, and this is a semicircle. Second part, they've asked us to find ACB. Now in triangle ACB, this is 45, this is 90, so what is remaining? 45. So this is 45. Here are the steps. Next, the sixth sum will be for homework. Let's do sum number 18. Again, diagram is given. O is the center of the big circle. AC is the diameter. Prove that AB is equal to BE. Here we'll use congruency of triangles. So we have to prove triangle AOB and EOB as congruent. So construction BO and EO. This EC was not required actually. So how do I prove this congruent? What do we have here? First of all, I know that AO is the diameter of the small circle as mentioned in the question itself. So this will be 90 degrees because diameters subtend a right angle on the semicircle. If this is 90, this is also 90. Also OA is equal to OE, radii of the same circle, big circle. I need one more thing. BO is equal to BO, common side. So RHS test. So both of them are congruent by RHS test. So AB is equal to BE, CP, CT. That is corresponding parts of congruent triangles. Here are the steps. Next. Now 19 Bravo will be for homework. 20th one. 20.2 cancelled because it's the same type as 20.1. 20.1, let's do it. Prove that parallelogram inscribed in a circle is a rectangle. No diagram is given, so we'll draw a diagram. And we'll have to write the given, because when the given is not given, it is compulsory to write the given. So ABCD is a parallelogram inscribed in the circle. So it's a cyclic quadrilateral. We have to prove it's a rectangle. Now parallelogram has properties like opposite angles are equal and opposite sides are equal and parallel. But rectangle has one extra property. Each angle is right angle. If only I can prove two of the angles, opposite angles, as 90 degrees each, then it's proved that it's a rectangle, because automatically they will also be 90. Now since it is a parallelogram, opposite sides are always equal. That's a property. But since it's a cyclic quadrilateral, we also know that the opposite angles are supplementary. That is, the addition should be 180. So if x plus x is 180, then x is 90, and hence proved that it is a rectangle. These are the steps. Next, the 21st sum is for homework. 22nd sum, let's do that. Read the question carefully and try to draw the diagram on your own. Let's see if you can figure it out. Pause the video. Okay, now I'm showing you the diagram. Check if you got it right. This is the diagram. We have to prove that AQB are collinear. That is, they lie on a same straight line. So our strategy would be to prove this as 90 degrees and this as 90 degrees. So if this totally is 180 degrees, it means it's a straight line. That means they are collinear. How do we do that? Construction, join PQ. Now, AP is a diameter of this circle, so definitely PQA will be 90 degrees. Similarly, this is also 90 degrees because this is a diameter, to mention all of that. And since both are 90 degrees and the total is 180, hence they are collinear. Next, the 24th sum is for homework and the 27th sum. Here the diagram is given and we have to prove AC is parallel to BD. Since they have mentioned AC and BD, I will just join them and no need to write construction because it was mentioned in the question itself. We have to prove them parallel. So my strategy will be join PQ. Now if this is X, then this will be 180 minus X because opposite angles of a cyclic quadrilateral are supplementary. Now if this is 180 minus X, then this will also be 180 minus X because this is an exterior angle for cyclic quadrilateral PQDB. So this is equal to the interior angle, remote interior angle is equal to the remote interior opposite angle is equal to the exterior angle. This is a property. The reason we will write is simple, exterior angle property of cyclic quadrilateral. Now, if this is X and this is 180 minus X, if I add them, the total is 180. So when the co-interior angles between two lines here, this is a transversal. So if the co-interior angles are supplementary, that is total is 180, that means they are parallel. There are three tests for parallel lines. One is the corresponding angles test, corresponding angles should be equal. One is alternate angles test, that is alternate angles should be equals Z. And here we are using the co-interior angles test, which is the co-interior angles should be supplementary, total should be 180. Next, 28th sum is for homework. Let's do the 30th sum and then the 35th sum will be for homework. That's it. 40th is cancelled. 49th is cancelled. That's because it's very easy. 57th is cancelled, out of syllabus. And even 40th is out of syllabus. Too long and too tough, it won't come. The 30th sum, the diagram is given. All I have to prove is SQ is equal to SR. Well, so clearly I have to prove this angle equal to this angle, which would make it an isosceles triangle, and so opposite sides are equal. But how do I prove this is equal to this? It is given in the question that this is the angle bisector. That means this is equal to this. Now, this angle is equal to this angle because they are cutting the same arc RS, so angles in the same segment. Whereas this angle is equal to this angle. It's an exterior angle of quadrilateral PQRS. So exterior angle is always equal to the interior opposite angle. So if this is equal to this, and this is equal to this, and this is equal to this, that means this is equal to this. And if this is equal to this, that means this is equal to this. Hence proved. Look at the steps. Of course, in exam, don't write this and that. Write properly like I have.